The topic of this video is solving nonlinear systems of equations by substitution or elimination. This is a continuation of the previous video. Alright, in our previous video we found that there are 4 potential solutions. We noticed that they all have an x value of 2, either positive or negative, and a y value of 3, either positive or negative, in all 4 possible combinations. Negative, 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 positive, positive, negative, positive, positive. We must now check all 4 of these points in both equations to determine for each one if it is indeed a solution to our system. Let's start with the 2 negatives. You'll see why in a moment. Okay, we're going to check the point -2, -3 in equation 1, as well as in equation 2. To do that, we simply have to replace every x or y with the corresponding value from the point, and we remember that parentheses are necessary. So, starting with equation 1, we have 3 times -2 in parentheses squared plus 4 times -3 in parentheses squared equals 48. -2 squared is 4, and 4 times 3 is 12, plus -3 in parentheses squared is 9, and 9 times 4 is 36, equals 48. 12 plus 36 is 48, so we get 48 on the left, 48 on the right. That checks. Okay, let's now check our point in equation 2 using the same approach. 2 parenthesis -2 close parenthesis squared minus 5 parenthesis -3 close parenthesis squared equals -37. Okay, order of operations says exponents are first. -2 squared is 4, then times 2 makes 8. Subtract. -3 squared is 9, times the 5 is 45. We're still using the subtraction sign. So 8 minus 45 equals -37. 8 minus 45 is -37, so we get -37 equals -37, and it checks. Because our point satisfied both equations, we keep it. We know it is a valid answer, and I'll put a check mark here. But that's just one point. We still have to check the other 3. But don't despair. The good news is, because of the signs, the algebra is going to be almost identical in each case. Let's see what we're talking about. Alright, so now we're going to check the next point, which is -2, +3. So this negative here needs to go away, here and here, here and here. Notice that the rest of the algebra is completely fine. This is the only place where a number changed. 3 squared is 9, 9 times 4 is 36, the rest of the algebra matches. Similarly, 3 squared is 9, 9 times 5 is 45, and the rest of the algebra matches. Therefore, this point is good. Alright, 2, -3. So now, this is positive, this is negative. This is positive, this is negative. Okay, so we've seen changes in both places now, but, as predicted, 2 squared is 4, times 3 is 12. -3 squared is 9, times 4 is 36, the rest of the algebra checks. 2 squared is 4, times 2 is 8, -3 squared is 9, times 5 is 45, the rest of the algebra checks. And the last one we have to check is +2, +3, so we erase the negative here, and here, here, and here. 3 squared is 9 times 4 is 36, 3 squared is 9 times 5 is 45, and the rest of the algebra checks. So as you can see, in this problem, it was really the first point where we needed to be the most careful, because if the first point was good, it really meant that all of the others would be good as well, because all of the x's and y's were squared, meaning whether x or y was positive or negative, x squared is going to give the same corresponding result. All right, so we have our final answer, these 4 points.